Okay, good afternoon, all of you. So we are continuing with dimensional analysis. The topic is continuing today. So we'll begin the session with solution of previous day's homework. So first of all, potential difference. Potential difference is actually work done in transmitting a charge between 2 points divided by the charge. If you say potential difference between 2 points, it is work done in transmitting the charge divided by the charge. So it is W by Q. So work done is force into displacement. Force is mLT minus 2. So work done will be that multiplied by L. So mL square T minus 2. Charge is current into time. So m I minus 1 L2 T minus 3. Energy is same as work done, so mL2 T minus 2. Power is energy by time, so mL2 T minus 3. Resistance, you know that I square R is power, so power divided by I square, so mL2 I minus 2 T minus 3 is resistance. Resistivity, you know, is resistance into area by length. Area by length has dimensions of length. So resistivity is resistance into length. So mL3 I minus 2 T minus 3. Refractive index is not having any unit at all. So it will be m0 L0 T0. There is no unit at all. Density is mass by volume. So m L to the power minus 3. So these are the different solutions of the previous day's homework, right? Now, in today's meeting, we are going to continue with dimensional analysis. In today's meeting, what we will do is we will have a look at dimensions of some physical quantities or some physical constants, which you can derive with the help of some formula. And some formulas may be known to you, but some formulas will not be known to you at all. So then what do? So what happens is that if the formula is known to you, you have to take the help of that formula and get the dimension. Now if the formula is not known to you, you can be rest assured that you are not an exception. So it will not be known to anybody of your, it won't be known to any of your contemporaries. So your teacher will provide you with a formula. You will have to use the formula provided by the teacher and find the dimension. So these are the two situations that can be possible. So either it will be through a formula which you know, or it will be through a formula which the teacher will provide you. So let's have a look at some examples. And so like I said, this was the last day's homework. I'm rubbing it now. So let us say you have a formula like this, f equal to g into m1 into m2 by r square. So suppose you have a formula, f is g into m1 into m2 by r square. So this is a formula to find the gravitational force between two bodies whose masses are m1 and m2. So in this formula, what we will do is, we will say that we want to find the dimension of g, right? So what do we want to use this formula for? We want to use this formula to find the dimension of g. So first thing we will say that g is f into r square by m1 into m2. So I want to find the dimension of g. So that will be dimension of f, which is mLt minus 2 into r square, which is l square, and dimension of m1 and m2 both are m. So ultimately the dimensions of g will be m minus 1, L3 and t minus 2, right? M minus 1, L3 and t minus. So this is the dimension of g. So capital G is a physical constant. It is the universal gravitation constant, and you can find its dimension by taking the help of this formula which you already know. F equal to g m1 m2 by r square is a formula which you already know. So from this formula you will get g is f into r square by m1 m2. Take dimensions, and this is the answer. Okay, next we come to another term, surface tension. This is not a physical constant, it's actually a physical quantity called surface tension. So this is something you have not heard of before. You have not heard of surface tension before. So your teacher will provide you with a formula. The formula is density into acceleration due to gravity into radius into h by 2. So density into acceleration due to gravity, radius stands for radius of the pipe or tube. Surface tension is actually related to liquids, so that liquid will be present in some pipe or tube, mostly tube. So radius of that, and height is the height of the liquid. So you have to find dimensions of surface tension. So to find dimension of surface tension, you'll have to do dimension analysis. So density is ml minus 3, acceleration due to gravity is lt minus 2, r is l, h is l, and the 2 which is below, it will not have any dimension because 2 is just a number doesn't have any dimension. So ultimately the answer will come ml0 t minus 2. So you can forget about L0. So mt minus 2 will be the answer. Okay, the answer will be mt minus 2. So that means what? That you will have to find the dimension of some physical constant or physical quantity by either using a relation which you already know. In case you don't know the relation, the teacher will give you the relation. You will have to use the relation and find the dimension. So that is the topic for today. So based on this, I am giving you the homework. Okay, so the question is that there is one equation, heat energy divided by time. So there's a conductor through which conductor can be electrical conductor, thermal conductor. So there's a conductor through which heat is flowing. So heat energy per unit time, the heat flowing through the conductor per unit time is K into area of cross section into temperature difference by length. So in this formula, K is called thermal conductivity. So heat energy divided by time is K into area into temperature difference by length. K is called thermal conductivity. So using this formula, you will have to find the dimensions of K. Okay, that is question number 1 of the homework. Okay, then the next is number 2, viscous force. So it's a kind of force. Viscous force means it's a type of force. Minus this symbol is called eta into area into change in velocity by distance. And this eta is called coefficient of viscosity. So viscous force is minus eta into area into change in velocity by distance, and eta is called coefficient of viscosity. So you will have to find the dimension of eta. So this is homework question number 2. Number 4, moment of inertia is mass into radius square. Number 5, electric field is force divided by charge. So these are the 5 homework questions. So you will have to find the dimensions of these things. Capacitance is charge by voltage. Moment of inertia is mass into radius square. And electric field is force divided by charge. So these are the 5 homework questions for today. Number 1, thermal conductivity. Number 2, coefficient of viscosity. Number 3, capacitance. Number 4, moment of inertia. And number 5, electric field. So these are the 5 homework questions, and today's homework has to be submitted by 9 p.m. tomorrow. That means by 9 p.m. Thursday. So I'll end the session. Thanks a lot. Bye all of you.